This next one is another differential problem. You need to use differentials to estimate this number. So first thing is my function is y equals x cubed. And my x value is that 3 right there. And my delta x is equal to 0.01. So with differentials, I take this guy and I find its derivative. And I'll write it as dy dx, and that's equal to 3x squared. Now I can multiply by that dx. I get dy equals 3x squared dx. So I multiplied by this guy. Now I change the d's over to deltas, and I get delta y, and this is where the approximation idea comes in. It's 3x squared delta x. Now I just plug my values in. So my x is 3, so that's going to go in here. My delta x is 0.01, and I'm going to figure out the delta y. So I get delta y is approximately 3 times 3 squared times 0.01, which gives me, that is then equal to 27 times 0.01, which I move the decimal twice, turns this into a 1, and this guy into a 0.27, so I get 0.27 times 1. So I get 0.27, that's my delta y, and you should know that I take that, so I know that if I plug in 3 to x cubed, 3 cubed, and 3 into this function is going to give me 27. So I take my y value and I add it to this delta y. So my answer is the y plus the delta y, so I get 27.27. Now, some of you good at recognizing patterns. You might say, oh, if I do 4 and 4 cubed is, what is 4 cubed? 4 times 4, 16, 64. Is that going to be 64.64? I wouldn't bank on that pattern holding all the time. So, in case I give you something different.